length methods when we write our loops to move through the indexes of a matrix. Okay, so if you remember back when we learned about arrays, we wrote a for loop that day, and I said we're going to write this loop over and over and again. Probably 100 times we'll write it, and it's the same thing today. So this for loop that we're going to write today for a matrix, okay, is going to be used by us probably 100 times over the next 2 or 3 weeks. So might as well learn it, right? All right, so here's how we'll work with this for loop. We'll first write a for loop to produce the indexes of the rows. Now, every matrix begins with row 0. So I'll start my loop at row 0. And every matrix, if it has 5 rows, then they're numbered 0, 1, 2, 3, 4. So you want to stop just before the number of rows that there are, or else you'll go out of bounds. And the way you can figure out how many rows there are, just like we saw right here, you just ask for the length of that matrix, and you will know then how many rows are in that matrix. So if we wanted to loop through matrix BB, we'll put bb.length right here. That's how many rows there are. Okay? And then we'll increment up to the next value. Now, I'm going to write a nested loop to handle the column indexes. Okay? Column indexes also always begin at 0. Oh, well, the columns, they might not be the same as the rows. Not all matrices are squares, they're just rectangles. So I'm not going to put bb.length here because I don't suspect that they're the same. If I want the number of columns, I have to specify which row I'm talking about. Now, if you're guaranteed in advance that it's a rectangular array, you could go ahead and put a 0 there, because row 0 is going to have the same number of columns as row 1, as row 2, and so on. Typically, I try to advise my students to just put row there. That way, if for some reason, if it's not a rectangular array, it will adapt as needed. Okay, so it's probably just better practice to put row there. And then we'll say COL++. Okay? Now, what this loop structure is going to do is it's going to produce all of the potential indexes. So like if we look at matrix BB, remember how its rows went 0, 1, 2, 3? Okay? Well, if you look at this outside loop, it's going to have values for row of 0, 1, 2, and 3. Those are the exact 4 integers it's going to produce, but it won't reach 4. Okay? And if you look at how this column works, column is going to start at 0, go to 1, go to 2. And since the length of every row is 3 in matrix BB, every length is 3, it will stop just before it hits 3. It will go 0, 1, 2. Now, this for loop is what we call row major order. What that means is it's going to take a particular row and it's going to look at every value in that row before it goes on to the next row. And then it will go to the row below that, and so on. And sometimes that's how you want to move across a matrix. Sometimes you want to move across a matrix by looking at an entire row first and then going to the next row. Other times you might want to look at an entire column first. It depends how the data was stored and what was put in there and why and any order to it. Okay? We'll look at that another day. But another day we'll look at how to write for loops to deal with column major order. Okay, now we got this loop structure. What can we do with it? Well, we can do all kinds of things with it. If I wanted to, I could take BB and I could say go to row, go to column, and increment every value, for example. Okay? And then this loop would move across every single value and make it one larger than it currently is. I could also just go through and say make every value 168. And then every value would become 168. Okay? Or let's say we wanted to print. If we wanted to print this matrix, then what we could do is we could say system out print I won't put an ln on it. Instead, what I'll do is I'll print a value from the matrix. Again, remember, to print a value from a matrix, you have to doubly subscript it. That's why we created these for loops, so that we could create those different subscript values, 0, 1, 2, 3, whatever's appropriate, okay? And what I'll do is, the reason I'm not going to do a println, I'm going to go ahead and put like a tab right here, okay? So there's our tab escape sequence, and you'll see why I did that in just a second. And you might remember this from earlier in the year when we were learning nested for loops earlier this year. We did this a lot. We would print a bunch of values from, like a particular row, and then once that inside loop finished, we would then print a blank line. You might remember we did a bunch of problems where we printed like stars and dashes, and we would print like a certain row of stars and dashes in some sort of pattern, and then we would go to another line, and so every time when the row finished, then we would drop down to the next row. So that's what this is going to do. This is just going to move the cursor down, okay, one row after it finishes. Okay, so we've seen that before when we first learned about nested loops. All right, let's take a look at what this looks like when we run it. Let's see what this appears to look like. All right, and those numbers, if you recognize them, those are the exact values of matrix B. And they're all there. It didn't miss any. And it put every thing of all the values on one particular row. So like 4, 5, and 6, 0, 1, and 2. It never went out of bounds, and it shouldn't, okay? Because of how we wrote the loop, everything stayed in order, and so on. If I wanted to print like 1490, I could. I'd have to use a column major loop arrangement. We'll look at how to do that again probably tomorrow. Okay, let's just try this real quickly. Let's just say we copied that whole thing, and let's put matrix CC there instead of BB. Now, if you remember, matrix CC is what we call a ragged array. It doesn't have that rectangular appearance to it. The way that we wrote this set of nested for loops, it shouldn't be a problem. It should be able to adapt to every row's particular length, and it should handle this just fine. Okay, and so there's the values of matrix CC. Okay, each row had a different number of values, and it's fine. Our nested for loop was able to just adapt and get the proper indexes every single time. And like I was saying, like with a nested for loop, you can do other things besides print. So for example, if I took this CC loop and just copied it again, and then maybe this time, instead of printing, let's try this. Let's say, like, for example, CC row column equals, I don't know, row plus column times 3 plus 8 or something. I don't know, just some weird math formula in there. And what that would do is that would assign a new value. Wait, what did I do there? Let's try this. Let's just do row plus column plus 8. All right, this would just go through and assign a new value to each one. Okay, so like 8, 9, 10, 11, and so on. So if you look at that number 10, that's its row plus its column plus 8. So it's in row 1, column 1, and 8. 1 plus 1 plus 8 made 10. So we were just like going through and assigning new values. You're going to use this nested for loop on your worksheets tonight. Okay, that's the base.